Okay, what I want to do now is just recap some of the work we've done recently on differentiation. So it's what we've been doing the last few lessons. It's about the gradient of curves. And what I'm going to do is go through some of the things we've looked at so far. Then I'm going to show you two more examples. And then you are going to have to try and reproduce those examples for yourself. But first, a quick recap. The topic we've been doing, it's been called differentiation. It's an area of maths called calculus, and it's all about finding the gradient of curves and then using that to solve problems. So a quick recap. If we've got the curve y equals x to the power of 7, and we want to find the gradient, what we do is we take the power number down to the front, and we knock one off the power. So the gradient of the curve y equals x to the power of 7 is 7x to the power of 6. If we do it on here, we bring the power down to the front. So here the 5 will be times by the 4, giving us 20. And we knock one off that power. And then here the 2 is times by the minus 3 to give minus 6. And we knock one off that power, which gives a power of 1. But we don't usually bother writing the power of 1 in, so we'd usually leave that as just 6x. And over here, if we do this one, the 2 will come in front of the x. We knock one off the power, which is the power of 1 we don't normally bother writing in. And if it's a number in front of a letter, we just end up with the number. Effectively there, that was minus 7x to the power of 1. And over here we had 1 times by minus 7, x to the power of 0. And anything to the power of 0 is 1, so we have 1 times minus 7, which is minus 7. So the key thing, if it's a number and then an x, it's just a number. Then any number just disappears when you differentiate. So going from here, we get 2x minus 7. So final thing, if you have ax to the power of n, and we had this before, the gradient is n times by a, and x is to the power of n minus 1. And we sometimes call the gradient dy dx. dy dx just means the gradient. Other things we looked at recently are the definitions of a tangent. A tangent is a straight line that just touches a curve at a point, doesn't cross it, it just touches it. And the gradient of the tangent is equal to the gradient of the curve at that point. And the other word we've looked at is the normal. The normal to a curve is at right angles to the tangent. So we've got a curve, we've got a tangent, and the line at right angles with the tangent, that is the normal. And then we'd also looked at the gradients. If we had a gradient of a tangent and the gradient of a normal. We said last time, if we had a gradient of a tangent was 2, the gradient of the normal was minus 1 over 2, or a half. The tangent had a gradient of 7, the gradient of the normal would be minus 1 over 7. If the tangent was m, the gradient would be minus 1 over m. And that's how we got perpendicular gradients. It's always minus 1 over the original gradient. Another quick recap of things we looked at. A straight line was y equals mx plus c, where m is the gradient and c is the y-intercept, where the graph crosses the y-axis. So the next part of the video, I'm going to go through another example. It's example 3. We had 2 last time. I just want you to watch it and pay attention, and then the teacher is going to give you out a sheet with example 3, the question written on it, and I want you to produce your own answer. And if needed, and I expect it will happen, your teacher can then show you me going through example 3 again to check you've got it right.